Okay, this is for section 7.6. And it's called Common Logarithms, and I'll explain that title in a minute. We have done a little bit of this already, and I'm going to do it by example. Use a calculator to evaluate to the nearest $10,000. So, for example, if they said the log of 6, okay, so on your calculator, find the log of 6. Yeah. Okay. Log of 6, and if they want it to the nearest 10,000, remember it goes tenths, hundredths, thousandths, 10,000ths. So you could do on the mode, you could go over 4 decimal places, 0.7782. The left column, LOG. Everybody agree with that? Okay, try another one. The log of 0.35. You get a negative 0.4559. Okay. You can't take the logarithm of a negative number, but I can get a negative logarithm. Yeah, because remember it's a power of 10, so you can have 10 to a negative power. Yep. And so we have log of 923. You get 2.9652. Agree with that? Okay, and last one on these. Say you have the log of 0.0005. You get negative 3.301010. Okay. Okay, and notice on all of these, I did not write down a base. Okay, it's understood that this is a base 10 if they use the word common logarithms. Common logarithms are understood to be base 10. And on the calculator, when you just type in log of a number, it's base 10 on the calculator. You can check any of these. For example, on the last one that we did, remember a logarithm is just an exponent. To check it, I think we've done this before, but go back. Right above the log is 10 to the x power. So do second function 10, and then it has that caret symbol. Okay, and then if you do second function answer right above the negative sign, it's filling that negative 3.3 in. Okay, and it should bring you back. Notice on mine it switches it back to scientific notation. So it's writing it as 5 times e. Actually, the calculator is writing it 5e to the negative 4. That's like 5 times 10 to the negative 4th power. Okay, and that's what this is if you wrote that back in scientific notation. Okay. Okay. The one thing too that I want to mention for any of you that go on into computers and computer programming, a lot of times on the computers when you're doing logarithms on the computer and programming, it's natural log. It's not. It's base e. It's not base 10, and you won't get into that natural logs until pre-calc or calc. So, but common logarithms are understood. You might want to put a note out the side. No base is written means it is understood to be base 10. Base 10 logarithms are called common logarithms. So if they don't write a base down there, it's understood to be base 10. What Anna was asking about the negative, you cannot take the logarithm of a negative number. So for example, try an example. Say you do the log of a negative 9 as an example. So do log of negative 9. And that's when the calculator will give you the error. Okay? The exponent or the logarithm can be a negative, but you can't take the log of a negative number. So this would give you an error on the calculator. Okay, the next and probably the main reason of this section is they will just ask you to solve. And say you get to 3 to the x power equals 15. And I want it to 4 decimal places. Okay? 3 to what power equals 15? Think about it. What's 3 squared? 9. 3 cubed? Okay, so it's got to be between 3 squared and 3 to the third. This is why we do logarithms. If there's a variable up as an exponent, that's when you do logarithms. Okay? So you can estimate it and say x is between 2 and 3, but I want it to 4 decimal places. Okay, so here's how you solve this problem. The first step, and don't skip this step, the first step is take the log of both sides. So all you do on the first step is write log in front of both parts. So first step, take the log of both sides. Okay, now from what we did in the notes day before yesterday, third law of logarithms says this exponent is going to go out front. So on the next line, it's x times the log of 3 equals the log of 15. And remember, you're solving for x. You want to get x by itself, so divide by the log of 3 on both sides. Okay, so x equals, so on your calculator, do the log of 15. You got to close the parentheses, divided by the log of 3. Okay, and I get, and it ought to be between, we said it was between 2 and 3. Wait, I put an extra number in there, sorry. Sorry, wrote that wrong. I got 2.4650. Do you agree with that? Okay. So, when do you use logarithms? Make a note. If x is up as an exponent, use logarithms to solve. The author won't tell you that. You just have to know if x is up as an exponent. Okay? Okay, now you try this one. Say they give you 42 equals 6 to the x power. Okay, so let's check. Take the log of 42 equals the log of 6 to the x power. And this helps you remember the third law of logarithms. This exponent goes out front. So you're actually doing that third law backwards. Okay, so you do the log of 42 equals x times the log of 6. And remember, you're solving for x. So do the inverse, divide by the log of 6. Okay, so we should get log of 42, close the parentheses, divided by the log of 6. I get 2.0860. Okay. Okay. Okay, last example. So you have 3 to the 7x power. 7x is up as an exponent. Is greater than 2 to the 5x minus 3 power. Okay, and I'm still wanting that x to 4 decimal places. Okay, so same thing. The only thing that's different between solving an equation and equal sign, if you multiply or divide by a negative, you reverse the arrow. So we're still starting out. Take the log of both sides. Make sure you can read your own handwriting. Make sure you can tell that's up as an exponent. Okay, so log of both sides. Third law of logarithms, this exponent is going to go out front. So you'd have 7x times the log of 3 is greater than, this quantity is going to go out front. So that means it needs to be in parentheses, 5x minus 3 times the log of 2. Okay. On this side, just going to leave that side alone. 7x times the log of 3 is greater than. Now you've got to multiply this log of 2 times both of these. Multiply that out. So you'd have 5x log of 2 minus 3 log of 2. Now we're solving for x. So you got to get every term that has an x in it on one side. Okay, so I'm going to bring this term over to the left side. These are not like terms. Okay, so you just have to write this out the long way. So this is 7x times the log of 3 minus 5x times the log of 2 is greater than a negative 3 log of 2. Follow what I did there? I just subtracted. They're not like terms, so you just write them down. Okay? Now, I'm trying to solve for what? X. Factor that x out. Factoring. Take an x out of both terms here. What's left out of the first one? Yeah, 7 log of 3, and then 5 log of 2 is greater than negative 3 log of 2. I'm trying to solve for x, so do the inverse. I'm multiplying by this, so I need to divide on both sides. Okay. Now, a critical part on this, on your calculator, is parentheses. You're taking this divided by this. Okay. Now, take a minute on your calculator and figure that. Okay. When you put this in, you got to be real careful. You got to put parentheses around the numerator. And on my calculator, it does an extra parentheses here, so I've got to close that, close it. I've got to put parentheses here, parentheses here. Okay, so final answer, you end up with x. You also have to check if we divided by a negative, but on this one, it is going to be x is greater than a negative 0.4922. Okay. Okay. Questions on that one at all? Okay. The assignment should be on, is it on the iTunes, you?